continue. We were saying that the next step is to, you are seeing the figure?
Yes.
Yes, that's it.
Okay. So we have sum of moments about A equals to 0. Okay, and please, when you do sum of moment about A, don't forget to include the reaction moment at A. It's true that when we take A, the moment of AX and AY is 0, but keep in mind that you have reaction moment MAX and reaction moment MAY. And as you know, the moment is a free vector. So I always take into consideration this moment if I do sum of moments about any point. So if you do about B or A or C or D, you should include the reaction moment, which is a couple moment. And it is having two components, MAX and MAY. So for sum of moments about A, I have the reaction moment at A, plus I should add moment of all forces about A. Now, as we said, for AX and AY, no moment. So we have the moment of, so plus moment of TDE about A. Just 1 minute. And plus moment of TBC about A. And plus moment of the weight about A, okay, equals to 0. Now I will express the moment of each force. So now equals to, instead of reaction moment about A, I will write the components. I have MAX along I and the plus MAY along J plus. Now to find the moment of TDE about A, I can take or AD vectorial TDE, okay, or AE vectorial TDE. So it's up to you. You can choose the easiest coordinates. Here both are simple because both have only two components. So let's say we take AD. So plus AD vectorial TDE, okay, and plus AB vectorial TBC. Okay. Now we still have the moment of the weight. So plus, for the moment of the weight, you will take plus AG vectorial plus AG vectorial, because you know that the weight is applied at the center of gravity. So plus AG vectorial the weight equals to 0. Okay. So to be able to solve for my unknowns, I should now find AD vectorial TDE, AB vectorial TBC, and AG vectorial W. I will start by AD vectorial TDE. AD vectorial TDE is equal to what? Is equal to, first, for point D, what was the coordinates for point D? Let us write them again. So for point D, we have along X, it is I, so it's, no, along X, it is K, so it is 3.
320.
320, okay. And for B, what was the coordinates? It's minus 220, I think. So minus 220, okay. Now, the next step is to write the vector. Okay, so vector AD, it's very simple because you have that A is 0, 0, 0. So vector AD is 3I plus 2J. Vectorial TDE, and TDE vector is TDE magnitude, if you remember, times the unit vector of DE. What was the components of the unit vector of DE? I minus 2J and a plus 2K. Okay. So this is over, and don't forget over 3. Okay, over 3. Now, if you want here, what you can do you can do two methods, or you can do the expansion, so term by term, and you can take TDE over 3 into factor because it's a number. I can take it outside, so I can write it's equal to TDE over 3 times 3i plus 2j vectorial I minus 2j plus 2k. Now, if you don't want to do the expansion because you have a lot of terms, you can do the matrix. Okay, so here we can do the matrix form or the expansion. Let us do the matrix form. If we do the matrix form here to compute this term, we put ijk, ijk. For the second line, it is 3, 2, and 0. And for the third line, it is 1, minus 2, and plus 2. Okay? And now we can do the calculation. Equals to, along I, what do I have? If I drop these two, I have 2 times 2 minus 0, so it's 4i. Along j, I put a minus. Don't forget to put a minus above j. So 3 times 2, 6 minus 0. So it's minus 6j. And along k, I have 3 times minus 2, it's minus 6. Minus 2, it's minus 8. So minus 8k. Okay? So now I can write that AD vectorial TDE is equal to 4i minus 6j minus 8k times TDE over 3 times TDE over 3. Okay, now I am done with AD vectorial TDE. Okay, I will continue with, so I will do the same for remaining terms. Okay, I will do AB vectorial TBC and AG vectorial W. When I do this, I will end up with 3 new equations. Okay, so let us continue. The second term is AB vectorial TBC. But the problem is that I don't have a space here, so let me. Okay, so I have to find now also AB vectorial TBC. AB vectorial TBC. Okay, I do the same approach. I have the vector AB is minus 2i plus 2j. Vectorial vector TBC is TBC over 3 times minus i and minus 2j and plus 2k. Okay, so if you want here, what I will do here, I will do the same matrix. Okay, but instead of here I have 3, 2, 0. Now I have minus 2, 2, 0. Okay, so now I will put instead of 3 minus 2. Okay, and I have for the vector, for my second vector TBC, it's minus I minus 2j plus 2k, so I have to put minus here. So I will add a minus before the 1. Okay, and now if I do for this vector, for the second one, it will be equal to, along I have minus 2 times minus 2, it's plus 4. Okay, and minus 2, so plus 2, it's plus 6. Plus 6 along I, so it's 6i. Now along j, I have a minus. I have minus 2 times 2, it's minus 4, minus 0, it's minus 4. Don't forget you have minus, so minus 4, it's plus 4j. Plus 4j. And along k, I have minus 2 times minus 2, it's plus 4, and minus plus 2, it's 6. Okay. Let me check something. Sorry, look, when we did along I, it's 2 times 2 minus 0. Okay, so it's 4. So please here, let us fix it. So here it's 4. Okay. So now this is our component for TBC vector, for AB vectorial TBC. Okay. So we still have the final component, which is AG vectorial W. So let me replace here. Here you have equals to 4i plus 4j plus 6k times TBC over 3 times TBC over 3. Okay. We still have the last component, which is AG vectorial W. To find AG vectorial W, I should look at coordinates of G. Okay. So for G, what are the coordinates? You have. Okay, let us look for G for the coordinates. First, as you can see here, this it's along minus Z, so it's minus H. Okay. Now to find X and Y, I know it is a little bit tricky, but if you look at your figure, okay, you have that G is at a distance from D equal to F. Okay, so you should take the coordinate of D and then you do minus F. Okay, so or you do K minus F, or you can take E minus D. Both will give you the same result. So for X, it's K minus F. Okay, so for point G, you have as coordinates K minus F along X. Now along Y, it's equal. Look, along Y, your plate is parallel to plane XZ. So all points of your plate will have same Y, which is equal to I. Okay, all points D, B, and G will have same I because the plate is parallel to plane XZ. So it is equal to I. Okay, and you have finally your component along Z, which is minus H. Okay. So now, once you have your vector AG, you can calculate AG vectorial F. So let us see what are the components. So for K, it is equal to 3. When you do minus F, F is equal to 2.5. So you have for G 0.5 as coordinate 0.5. And we have for I, it is equal to 2. And H is equal to, where is H? H is, I cannot see it here. H is 1, so minus 1. Okay, so now you have 0.5 for G. G is 0.5 and minus plus 2 and minus 1. Okay, now to find the moment of weight, you do moment of weight is AG vectorial W, and for W it's minus 50k. So for the moment of the weight, it's very simple. No need to do a matrix because you have only one component for the second vector. So it's 0.5 I plus 2j and minus k vectorial minus 50k. If you do the expansion, you have first I vectorial k, it's minus j, okay? And you have already minus, so plus, so equal to plus 25 times j. Now, j vectorial k, it is plus I, okay? And you have a minus, so it's minus 100 minus 100i, and k vectorial k is 0. So now we found moments of all our forces. All we have to do now is to replace in the moment equation. Okay, when you replace in sum of moment about a equals 0, as we did for the force, you obtain 3 equations. So what are the 3 equations? Sum of moments about a along x equals 0, and sum of moments about a along y equals 0. So you just compare along I, j, k, you get 3 new equations, okay? And therefore you close your system. You have now 6 equations, 6 unknowns you can solve, okay? So we can see it here in the solution. You can write a set of 6 equations with 6 unknowns. The only difference between what we do and they do, it's the same method, but they represent it in another way sometimes. Okay, so here they directly did the replacement into the 6 equations, and you got 6 equations with 6 unknowns. You can try to solve the system to make sure that you will obtain the same results. Okay, any question on this problem? So we are done for today. We continue next time. And if you need anything, if you can text me whenever you want. Bye bye.
Thank you,
Thank you,
Doctor.
doctor.
Okay, thank you, doctor.